If you have any questions, just let me know, please. So today we will start our first lecture in the Structures 2 course. And I just opened the landing page of the course. So this week we will only have lecture for Superstructure and a tutorial for Superstructure. There is no lecture for Substructure this week. So the Substructure lecture will start from week 3. Okay. So today, our Superstructure Zoom session starting from 1 to 3 p.m. And the Superstructure lecture will be in week 3 on Thursday at 11 a.m. to 1 p.m. Okay, so this is the lectures time and tutorial time on Wednesday, depending on your class group. And here you can check the course timetable to see what topic we will be discussing today. For example, today, the superstructure component, first lecture, week 1, we are looking at introduction of loads and load bases and some information about the course and assessment and so on. Okay. During the semester, we will have 2 guest lecture for concrete mixing and concrete glazing and concrete quality by Dr. Tom Bell. And we will have also a guest lecture discussing the reinforcement and reinforced concrete structures by Eric Liu from Syria, the Steel Reinforcement Institute. Okay, so welcome to all the students join the lecture. I just brief introduction before starting the lecture. We are now looking about the timetable, looking at the timetable. So again, you can check the timetable from the landing page of the course. Welcome to Structures 2. Okay, and here also you can find the announcement, any announcement or any important thing I want to communicate with you, I will post here in the announcement section. And you can read the course introduction from here. And here, this section, how to download the Australian or how to access the Australian standard and a list of what Australian standard we will be using during the semester. And here is the assessment. In this course, we have 3 assessments, 2 assessments during the semester, superstructure project and substructure assessment. Both of them together are 50% of the total weight of the course. The superstructure project is 35%, and the substructure is 15% of the course, of the total weight of the course. And for the examination, we have a final examination. The final examination will be weighting 50% of the total weight of the course, and it will be 2 hours, and it will be online test, but the time will be decided later. So this is the 100% of the total weight of the course distributed between 50% for assessment during the semester and 50% for the final test. Here in this section, you can find some forums to discuss your queries. If you have any queries about superstructure, you can post it here. If you have any query about substructure, you can post it here. And here is the Zoom session. So the Zoom session recording will be transferred to this section, the recording section, and I will also post it to the announcement section, so that if you didn't attend today, you can watch the video or the recording later. And here is our first week of the course, the superstructure component part. So here we have, this is the objectives we will be looking at, and here is the tasks. So your task this week is to watch some concept video about the design process of steel and what are stages of the design, the structural design, And you can also read this article about strengths of material, and you can have a look on the Australian Standard 1170.0 or the Structure Design Actions General Principle Standard. And again, here is another source of how to download or access the standard. The standard this year will be accessed using the engineering workbench database. So if you have used the standard last year, it was with a different provider. So this year it has been changed to engineering workbench. Just try to access the standard, and if you have any issue with that, just contact me and I will try to help. Okay, so now let's start with the first part of our lecture. Part 1, course general information. So I will share the screen with you now. Okay, all of you can see the screen. Any problem or any question you have? All good? Okay, so now we can start our lecture. So welcome to Structures 2. My name is Ahmed Sheta, and I'm lecturer of structural engineering at UniSA STEM, University of South Australia. My current office is at Mount Lakes campus in room B222. And this is my phone number, and this is my contact email or personal email. If you have any query or any problem, just feel free to contact me and I will try to help. Okay, so again, just in details, what are the assessment we have in this course? So in this course, as I mentioned, we have superstructure component and substructure component. The superstructure component, the superstructure component is larger in weight of this course. So it is about 2/3 of the course. It's about 67% of the course. And the substructure is only 33%. Okay, so the assignment or the assessment we have during the semester is superstructure project, which is 35% of the total weight. And for substructure, we have 15%. And this is in total 15% assessment or work during the semester. The other 50% is for the final examination. The final examination is distributed as follows: 33% of the total weight is for superstructure, 17% of the total weight for substructure. So this is the assessment weights. So in total, the superstructure part is 66.67% of the course, and the substructure is only 33.33% of the course. And this reflected on the lecture and classes of the course. So for the superstructure part, we have 12 weeks lectures every Tuesday from 11 to from 1 to 3. And we have also face-to-face tutorial classes. I will be delivering the face-to-face tutorial classes on Wednesday based on your group. We have 3 classes on Wednesday, 2 to 3, 3 to 4, and 4 to 5. For the substructure part, we have only 10 weeks every Saturday from 11 to 1, and there is no classes for the substructure part. So if you have any query about the substructure part, we can discuss it on the lecture of the substructure part, or even you can contact me and to discuss. Okay, so this is an important hint or important note you need to keep in mind for this course. So to pass this course, you'll need to get at least 40% of the final exam. So 40% of 100% of the final exam for the superstructure and substructure combined. And in total, you need to get 50% overall of the assessment and final exam to pass the course. So 40% at least of the final exam, 50% overall to pass the course. So this is the criteria of passing the course using the final exam and the assessments during the course. So again, as I mentioned earlier about the course communication, we have tutorial sessions for the superstructure part. And also you can use the discussion forum to use to post your queries or question. And you have individual dialog box you can use as well. And also the consultation time to answer your question is from Monday from 12 to 2 p.m. If you have any question, you can contact me during this time and have a short meeting. Okay, so also you can use the personal email to send any query if you want. Okay, so we have only one assessment for the superstructure part, which is the design project or the project. This project will be like group work. We will, starting from next week, we will form groups of 3 persons or 4 persons to work together on the project. So I will post a link from next week so that you can join the group to work on this group. This project will be design of structure member of a domestic shell. So we will be going through the member of domestic shed, mainly beams and columns. So as you know, for domestic shed, we have like roof sheeting, purlins, beams, columns, footing, and so on. So we will be only focusing on the beam and column design. So we have 2 parts of this project. So 2 submission. Each submission is 50% of the project. So in total, it is 17.5% of the whole course or the total weight of the course. The due date of the first part is Monday, 28th of April at 5 p.m. And part 2 will be 50% as well, which is 17.5% of the total weight, which is due on Monday, 2nd of June, 2025 at 5 p.m. Okay. So this is the assessment of superstructure part, the project, and again, it is a group work or group or team work. And here is a list or some of the learning resources we will be using. So we will need to use some of the Australian standards that will help us in the design and calculation of loads. So the main ones is AS 1170.0 and 1170.1, and these are dealing with the structure actions of loads like dead load, live load, and so on, and also the load combination between the different type of loads. And the main important one is the AS 4055, which is the wind load for housing. So we will be using this standard 4055 to calculate and determine the wind speeds and wind loads and wind pressures on the building using the Australian standard AS 4055. And here are some recommended references if you want to increase your knowledge about mathematics, for example. So we have mathematics for Australia version 9, and also another one about understanding structure and steel designer handbook, because we are mainly focusing on designing of steel structures. And also we have some resources about Reinforced Concrete Basic by Warner and Foster and Kilpatrick. Okay, the course material or the course slide will be posted weekly, so you can find them using the course Learn Online website. And I will also post the assessment one, at least the Superstructure project assessment by end of this week. So you can also have a look on the details of the project so that we can discuss from next week. And here is the course objective and what we will be looking at during the course. So for the superstructure part, our course objective for this part is understanding the different type of loads and their features. So for example, if we have a warehouse or a shed like in this picture, what are the structure element that supporting this shed? For example, as you can see here, we have rafters, roof sheeting, purlins, and columns here. So we have columns, beams or rafters, and purlins in the longitudinal direction. And also we have bracing. So we have different members and also different loads. So we need to find the loads of or understand the different type of loads on this structure. And we also will learn how to determine the load using the Australian standard. So the Australian standard we have, as we mentioned, AS 1170.0 and 1170.1 to find the loads. Okay, sorry, this one is not very good. Okay, and also we will be looking at the load bus concepts, how the load is transferred between the members until reaching the ground. So as you know, the load need to be transferred to the ground. So we will have load traveling in the rafter, for example, then to the column, then to the footing, and the footing will distribute it to the soil. So similarly in the other side. So the load transfer from the roof sheeting to the purlin to the rafter and then to the column and to the footing and finally to the ground or to the soil. This is the load bus. And also we need to understand what is the design concept or what is meant by design. The design mean after we find the forces in the member, so we need to select a member for the column, for example. As you can see, this column is, for example, universal C column like that. So we need to find what is the size of this column or what is the size of this section. This is what is meant by design concept. So we need to determine or to find what is the size of the member we will be using to for this column or for this rafter or for this purlin and so on. Okay, and also we will learn how to design some simple structure component using the Australian standard. So we will be following the Australian standard to design the member. And as I mentioned earlier, our focus in this course will be only on columns and rafter or columns and beams. No bracing, no purlins, and so on. The last thing we will learn here in this superstructure component is the concrete quality and concrete mixing. So we will learn, or Dr. Tom Ben will teach you how to mix concrete, what is the mixing or mixing procedure and the mixing proportional to achieve certain properties of concrete. Also how to, similar to this image here, how to assess or evaluate the quality of concrete and how to achieve good properties of fresh and hardened concrete. So are the main objectives of the superstructure component. And for the substructure component, we will be also looking at some key concepts of geomechanics or geotechnical engineering, including site investigation. So we will look at the site and soil investigation and the properties of soil and some essential parameter of the soil properties. Also, we will be looking at landslide or slopes and stability management of these slopes, ground problems and how to improve the soil properties. Also, design of footing like raft or mat footing and bed footing and pile footing. And also, again, the ground improvement. And the last part of the substructure part is the root pavement. So we will be looking at the root pavement and how to achieve the required strength of the root pavement and what type of root pavement and so on. And this images so for example here some of the soil stability problems. So for example here due to like settlement of soil, there is some cracks in the masonry wall. So these cracks will cause maybe failure of the building, so that we need to check or study the soil properties to improve the soil so that we avoid any settlement like that and avoid any failure of the building. And here on the right hand side we have footing design. For example, if we have like steel column, so how to fix this column to the ground or to the footing. So this is the footing design. So we will be also looking at the footing design during the substructure component. And here is again the course timetable. It's already on the course online website, Learn Online website. But here as well, you can see the topic we will be studying. So in week 1 and 2, there is no substructure lecture. So we have only superstructure lecture. Today we are looking at the introduction and of loads and load buses. Next week we will be looking at dead load, and we will go step by step on how to find or calculate the dead loads. And from this week as well, we will be starting the tutorial classes from tomorrow. So Wednesday, our tutorial classes. It is face-to-face tutorial, so please try to attend the classes if you have any questions. So it will be easier to solve it during the face-to-face tutorial. So we have 6 weeks before the mid break, and week 5 and week 6 of the superstructure will be delivered for concrete material and placing and theory of mixed design and reinforced concrete durability by Dr. Tom Bell. And here is the second part of the course timetable. So we have also another 6 weeks after the break. So we have only one guest lecture in the second part by Eric Long from Syria, the Steel Reinforcement Institute. This lecture will be talking or discussing the reinforced concrete and the reinforcement of the reinforced concrete structure. And in week 12, the last week of the class, we will have revision in the lecture of the superstructure and the project presentation for the superstructure project in the tutorial class. So for the project, we will have some portion of the project weight on the like oral presentation of the project. And also in week 12 of the substructure part, we will have revision lecture about the final exam. Okay? And thank you. Do you have any question for the first part of the lecture today? Have any question, guys? If you have any question, you can put it in the chat and I will respond to you. Okay, for the project presentation, we will you will we this is very early to discuss now, but uh anyway, the last class we will be doing like oral presentation to present the project. Oh, so you mean what to bring to this class? You don't need to bring anything to the class. You just come with your normal tools like pen, notebook, and so on. If you want to write down any notes and so on. But nothing special you need to send to come with in the class. Okay, in the class I will be mainly explaining to you and solving the problems with you. So like mainly I will be explaining like question and solving problem with you. So nothing to bring, but maybe notebook and pen if you need to write down the notes I discussed with you. Okay, the group assignment will start. It will start maybe from next week. We will just try to form the group from next week, and then week by week you can apply what you learn, the concept you learn in the lecture and tutorial in the project. So from next week, I will start introducing the group project with you. What happen if you unable to find the group? The group will be like I will share with you a link so that you all the group will be suitable online, so you can join the group. So any group of 2 or 3 you can join. If you are any of you can't find a group, so you may do the project alone, but this will be very hard because the project will be long. So it is better to join a group so that you can share the workload together. Okay. Do we only have no? I will no other teacher, so I will be the teacher for the superstructure and substructure parts, and also in the tutorial. So no other teacher will be helping me in this course, so only me. For the project, I don't prefer you to work as an individual for the project, so that I can't discuss the marking criteria for that. But if if it is a special case, we can discuss later if somebody decide to do the project alone. But I don't encourage you to do so because the workload for this project is a little bit big, so it's better to share the work between 3 or 4 members. Okay. Also, to make sure that everyone will work in the project, we will have the Spark. This Spark is a software that assesses the group members' contribution in the work, so that before or after just after submitting the project, the first part. So I will share with you link to Spark so that you can share your thoughts about the group members' contribution to the project. Okay. What is the rate of student buzz the course? This is normal, like other classes, but for this year, because this is I am the course coordinator for this course this year, so maybe it is different. But usually it is not very high or not very low, so it is like maybe 80% or 85%. Okay. So for structure two, it is building on structure one. So the concept you have learned in structure one will be used in structure two. So some of you ask if it is hard as structure one last year or similar. So was structure one hard or easy course last year? So that I can tell you. Did you feel structures one hard or easy course? It was hard. Okay, so if it is, this is the hard part, so I will try to help you as much as I can and provide you with the right sources, resources to pass the course and get high mark in the course. But it depends also on your work. Okay, so we will try to make the course as easy as I can for you. But the main thing we need to do in this course is to learn the required concepts. So this is the main point I have, just to learn. So if you learn or if you're willing to learn, so the course will be easy and I will try to help you to get higher marks. Okay, for will there be any assistant for this course? Yes, as I mentioned, we will have lecture and tutorial class. So for the superstructure part, we have tutorial class on Wednesday, and I will be doing the tutorial class with you face to face in City East campus starting from tomorrow. For the substructure part, we will like solve example and like the tutorial we embedded in the lecture. So I will try to solve some problems in the lecture. So don't worry about assistance in this course. So I will try to do my best to assist you during the course. Do you have any other question? Tutorial gonna be recorded? The tutorial are face to face, so if someone will volunteer to record, I don't mind, but they are not online to record. The other option is maybe I will use the laptop and do it as a Zoom session. Yeah. Okay. No worries. I will try to use the laptop to do the face-to-face session instead of using the normal board, whiteboard. So I will use the laptop to solve the question and explain to you, and so that we can have a chance to record. Okay, no worries. So it will be good to have records for the recording for the tutorial as well. Any other question before we go to the second part? Can you also record with the camera on, like of the board, so we can see? So what you mean? Can you also record with the camera on? You mean show my face? No attendance will be taken. Okay, yeah, sure. I will record the content of the class. So I will use the like the laptop to explain on the laptop. So instead of using the board, so I will using the laptop and open Zoom session to record the meeting. So don't worry about recording the tutorial. I will try to record it. For the attendance, I'm not keen to take the attendance of the class, but it is better for you to attend the class so that you can follow the explanation we will do in the class, and also it is better to like propose your queries during the face-to-face class. Okay, no worries. If you are working, so I can understand that. No problem. Okay. So if you are working and you can't attend the class or the lecture, there is no problem. So anyway, the lectures are recorded and posted to the course website, and I will try also to record the the tutorial session. Okay, so no worries about recording. Any other questions? Okay, thank you. So I will jump into the second part of the class. Just a second. Okay, so now in the second part or part two of the class, we will be looking at some introduction about the structural engineering and the loads and load balances and so on. So if you have also any query during my explanation, just please let me know and I will try to help. Okay, so for this part, we have introduction to structural engineering. And firstly, I want to ask you, what are some concepts you have learned in the Structures 1 course, if you remember any of it? So here's some of the concepts. Do you remember any of this one? Like forces, moments, equilibrium equations, stresses, strains, dead and life load calculation using standard, structure analysis like truss analysis or beam analysis, and structure design using steel capacity tables. So how many of you can remember these concepts? If you can respond in chat or raise your hand. Do you remember these concepts? Or have you learned this concept before? Yeah, that's good. Thank you, Hailin. Thank you, Samuel. Okay, so these are important concepts so that we will use them again here in structures too. Okay, no problem. So mainly our work will be about structure analysis and structural design. So we can't do structural design before structural analysis because you first need to find the analysis, the forces and the members, then use the forces in the member to design the members and find the suitable members. Similar to what you have done before in structure 1. So for example, if you did the truss project. So you have loads on the truss and find the reaction, find the internal forces, then use the internal forces and the design capacity table to find the suitable or appropriate member size. So we will be doing something similar to that, but we will go in details about how to find the load, dead load, live load, and wind load. Then use this to make or perform structure analysis of beam and columns. So here we can add beam and column analysis. So this will be our main focus, beam and column analysis in this course. Okay. And then use this beam and column analysis or the forces in the beam and column to design the members. Okay, so this was some concepts you need to know or you need to memorize from last year. And the next is what do you think is a structure? What is the structure? Or what is a structure? Do you have any ideas about what is a structure or what is example of structure? So structure is any form of construction that can support load or resist applied loads or transfer the loads to the ground or the foundation. So this is a structure. Anything that do something like these three steps or three parts is considered as a structure. So the structure supports loads coming from dead load or live load like people, furniture, and so on, and also resists some other applied load like earthquakes, wind load, snow loads, and so on, and then transfer all these loads applied to the ground through the foundation. Some example of structures like residential houses, shopping center, bridges, dam, car parks, sheds, warehouses, mining and oil structure. So all these are type of structures, and we will be dealing with some of them like the shed. So in this course, we will be designing a shed. This is the summary or the objective we will be doing, design some elements of a shed. Okay, so these are some example of structure, and here is some photos of structures that you can see around. So for example, this is a warehouse under construction. So you can see columns, got columns, and we have rafters at the very top here. We have also purlins. These are purlins here at the top here, purlins. We have also some diagonal bracing, as you can see, diagonal bracing. And under the column or under the group of column, you have the foundation. So as you can see, it is like mat foundation. So the structure design means is to find a suitable member for a suitable cross section for each member. So as you can see, the member has different sizes. So not all the member are same because they are carrying or supporting different loads. So that each member has different size. And our rule is to find a suitable cross section for each of this member and make sure that the load will be transferred from the top of the structure here to the ground or the soil here in a safe and economic way. So our rule is to design a safe structure and also economic structure. Another type of structure like this shell structure, that is some of the advanced structure. And also here we have some reinforced concrete, also shell structure. So it has some architecture design. So the difference between architecture design and structure design is the architecture can imagine the shape or the external shape of the structure or of the building, but the structure engineers and the construction manager are responsible to execute this shape and make it safe in real life. So this is the role of structure designer or structure engineer to find the safe members for this one, safe member for this part, safe member for this part, and make sure that this structure will sustain all the applied loads that is applied on it. And this is another also shape of structure. So it is like multi-story building or mid-rise building with some architecture design like overhanging parts and so on. So all of this is designed by structural engineers. And here is another type of structure, which is the cable stayed bridge. So this is a type of bridge. As you can see, the bridge deck is going horizontally. And this bridge deck is suspended to the pylon here in the middle using some cables. That's why it's called cable stayed bridge. So the deck is supported by the cables, and the cable supported to the pylon or the middle column here, and so on. This type of bridge provides higher, like larger spans and less material, so that it is good to use advanced techniques in design and construction. This is like a ship, so it is ship from timber. So this also can be considered as a structure. And this is another type of structure, which is reinforced concrete structure. So you can see here the columns, the beams, and slabs. And all this is steel shuttering or steel formwork. So as you know, to form the concrete, you need like timber formwork or steel shuttering to form the concrete and hold the concrete until it is hardened. And this is another simple like bird house of can be considered also as a structure. So it is from timber. So all of these buildings can be considered as structures because they are resisting and supporting loads and transferring loads to the ground. Some of them are simple, like this one. Some of them are complicated, like this one, for example, or this one, for example. Some of them are systematic, like this one. So all of them are considered as a structures, and you can see them around in your normal life. Okay, so let's start some of the revision about what you have learned already in structure one, for example. And we will start firstly about what are structure loads. What are structural loads we have in structures? We have mainly two types. The first type is gravitational or vertical loads. So gravitational or vertical loads, these are the loads that acting vertically or in the gravity direction. So similar to here, as you can see here. So these loads are going downward. So it is in the gravity direction. The example of this gravitational type is the dead load and life load. Because dead load and life load are weights, so they are all the time or mostly applied in the vertical or gravitational direction. That's why it is called gravitational load. Another type of loads is not vertical, but it is horizontal or lateral loads. One example or two examples of lateral loads are wind and earthquake or seismic loads. So for example, this building here, we have the wind blowing to the building. So the wind is blowing horizontally. So the wind causing horizontal load on the building. Another example here in the bottom image, we have earthquake load or seismic load due to the Earth's movement or the waves in the Earth's movement, which cause some vibration of the foundation and the building, which is the earthquake loads. So example of lateral loads are the wind and seismic loads. We have also some other type of loads, like we can classify as other, like flood and soil loads. For example, here, if you are in a city or a suburb susceptible to flooding, so the flood or the water, excess water will cause some extra or damaging on the building or the structure. That's why we need to consider it in design as well. Another one is earth or soil loads. As you can see in the bottom image here, we have some earth pressure acting on the side wall of the building, which can cause failure. So we need to consider it in the design. Some other types like snow and rain loads. For some countries or some states here in Australia, we have snow. So the snow also, when it when the snow stays on the roof, for example, you need to consider the weight of snow when designing. Also, the rain loads, the weight of water due to rain or the excess water due to rain will be considered in our design as well. In our course, we will be only focusing on dead load and live load and also wind load. So this is the only three loads we will be considering or including in our design. The other type of loads you can read about for your knowledge, but not considered in our course, not in our scope. And this other some other type of or some example of loads, like for example here, if you have like a retaining wall and you have soil higher in one side and to the other side. So this soil here on the left side is causing soil load or earth pressure on the retaining wall. Here for like for example offshore structure or oil and mining and oil structures. So this structure are mainly constructed in the deep water away of the shore, so that this structure will be subjected to wave load from the water, the sea water or ocean. Another example of load is the water pressure in earth in the water tanks. For example, this like a drinking water tank to supply suburb, for example. So there is some water load on the walls of this tank. And here we have earthquake loads. So the earthquake loads can be like that. So due to the wave movement or the movement of the soil or the ground, it causes some waves on the structure. Here is another example of load, which is impact load. So impact load like a car collided to a structure. So this is a load that can cause damage or failure of the structure. So sometimes in some areas or some type of structure, we need to consider impact load. Another type of load is the blast load. Blast load is like coming or resulting from explosions. So in some, for example, nuclear plant or something, so you need to design the walls and slabs of this plant to resist the blast load. So these all are some example of loads. Do you have any question about loads or about the first part of this slides? Do you have any question? All good? Okay, so before we continue, so we can have a short break, so we can rest until like like 2:05 or 2:06, so that we have like 8 or 10 minutes to rest, and then we continue. Okay, so we will have a break for 8 to 10 minutes and then start again. Thank you. So after we learn about some example of loads, so now we want to understand what is the meaning or what is the definition of the term design. So design always involves some serious decision that made often without sufficient information about certain factors, and you need to make a design decision that will influence what the structure will look like. Because in the design stage, we don't have like 100% certainty about the loads that will be applied to the, we have like estimation for sure, but we don't have the exact value or the sufficient information for design. So this is actually the main criteria or the main risk we face during the design, that we don't have 100% certainty about the applied load, and also we are not 100% sure about the quality of material or the strength of the material we are using in the design. So that the design process need to have some factor of safety margin, so that you don't risk to design uh, at the exact values you estimate. So you need to have some margins of to ensure that you have safety margin in the design. Okay. So what is the engineer's role in structural design, and what is the construction manager role in structural design? So the role of structure engineer or construction manager deals with engineers. So you need to have acceptable probability of satisfactory performance during the intended life of the building or of the structure. So during the design, we need to have some acceptable satisfactory performance during the life of the building or of the structure. This will make sure or ensure the structure can sustain the loads, like dead load, life load, and resist the forces like lateral load and earthquake loads. Ensure that the structure remains fit for use during the design life of the project or the structure. Ensure appropriate durability to minimize the maintenance required during the life. Okay, so we need to make sure that the structure will stay safe during during its life to resist the load, and also nothing like damage, no partial damage, so that it is fit for use for people who use or access the building. And also we need to make sure that the structure is durable, so we don't need to spend or do some costly maintenance during the cycle life or the design life of the building. So this is our rule to make sure about these 3 points. And here, if some different type of building, like it is just shows you the certainty and some of the criteria we need to consider during the design. So for example, here we have one simple structure like cheap shed or something, and this is a residential house. This one is a hospital, and this one is a nuclear power plant. So when you are designing this type of structure, you don't use the same criteria in designing all of structure. Because for example, if this cheap cheap shed fail or collapse, the the damage happen or the consequence of this failure is not as much as the damage or the failure of a nuclear power plant. So when you are designing a building, so the importance of the building also play a key role in designing the building. So this will affect the margin of safety or the factor of safety I was explaining earlier here when we was talking about this part here, or sorry, this part here. So the factor of safety will be affected by the importance of the structure. So, for example, here as well, if we have like an earthquake or a volcanic explosion or something like this, so the damage will be everywhere in the city, for example. So the hospital, which will cure the patients or cure the people who are affected by the earthquake, need to stay stable and not damaged or not collapsed to serve the people. So you need, when you design a hospital, you need to be more uh, increase the factor of safety or the margin of safety when you're designing this type of building. So this is just some thoughts about how the type of building affects the design process. Okay, again, the main thing we are looking at in this part is the risk. So when you design a nuclear power plant, the risk is too high, so that when you are designing, you need to consider higher factor of safety to avoid this risk or to minimize the risk with this type of design. Okay, so for example, here we have the first thing we need to make sure about in the design process is structure should be able to sustain the load and resisting the forces during its design life. So for example, if we have snow like that, so when the snow drop on the building, if it is not considered in the design, as you can see, what happened to the roof of the building. So due to the snow, the roof has collapsed here and the building has collapsed here. So this means that the snow was not considered in the design. So if you are living or designing a building in a city that is susceptible to snow, so you need to consider the snow in your design. For example, if you are living in a city susceptible to flooding, so the building design or the structure design should include the flood loads. So this is something you need to consider when you ensure the structure can sustain load and resist force. So you need to make your research and investigate what all the type of loads that can be applied to the building you are designing. So it is important to understand that there is dear consequence if you get it wrong. So if you, for example, neglect the snow loads and snow comes excessively like that, so the building will collapse. So you will be the responsible person about this failure. So you must understand your professional responsibility. So it is the responsibility of the designer to include or consider all the design load in the design process. These are two videos you can watch, like showing an example of some of the deal consequences happened due to bad or poor design. Okay, and also in this slide, you will see some three other videos showing also the construction, because the construction manager is the executive person in the construction site, so that when you receive the drawings as a construction manager, you should also have some understanding of the design so that you can comment if you see something that is not considered in the design process or something was ignored, so that you can have also your contribution in the design And here are three examples of some of the consequences that happen due to poor design and also uh, poor uh, poor decision from the construction manager. Okay, so the second one is ensure that structure remains fit for use. And here we have also two examples. The first one to the left is an example of a bridge. This is a steel bridge. As you can see, the bridge has settled or sagging in the bridge due to excessive deformation or excessive deflection. So this excessive deflection may be due to some of the loads was not considered in the design. So this also one thing we need to consider in our design is the deformation or deflection. So even the structure is still safe, I mean it is not collapsed yet, but as you can see, the sagging in this bridge will cause the cars will not be easy to use the bridge. So this affect the use of the bridge or the use of the structure. So we need also to make sure that first step was the structure not collapse. Also, the second step, the structure still fit to use. Okay, so this is also another important thing. And as you can see in the right-hand side picture, an example of a slab or a roof, which is also has a big sagging in all direction. So this sagging will also, the structure is still not collapsed yet, but it is not fit to use. So if you are living below this roof, so you will feel worried about the roof falling on you. And if you live on the top of this slab, so also you will not, because the slab has already big sagging or noticeable sagging, so you will not be able to use the structure of the roof appropriately. So this is another criteria need to be considered in our design. So the structure need to remain fit for use. Okay, the third part or the third criteria of design is to make sure that the make sure that or ensure that the structure is durable or to minimize the maintenance required during the cycle life of the structure. So when you're designing a building, so you need to make sure it is durable and will need minimum maintenance during its life. So that it is better to use like durable materials like concrete, for example, or steel and so on, because these materials are durable, was proven as durable and needs very minimum maintenance through the lifetime of the building. And this is an example of durable structure. As you can see here, this building or Bonto Fitch Flat Arch Bridge was built in 1345 AD. So you see how long this bridge lasts. So we need to, when we're designing, to consider long life of the building so that it can stay for longer with less maintenance. This can happen if we use in the construction material which is durable and sustainable, so that it needs less maintenance through its the life of the building. As you can see here, here is another example of one of the good designs here at the back. So the building didn't collapse even though the surrounding buildings failed. So for example, in some earthquakes or some bushfire events, some of building collapse and you can find one or two buildings that stay stable without failure. So this means that the designer of this building was a good designer and he considered all the expected loads in the design so that a good design will pay off in some event like that, like earthquake events, bushfire events, and so on. So that you need to consider everything in your design, because if you neglect any load or any small detail, so it can cost you. Okay, and here is a video about the design process. So we can have watch this one. So I will open the video for you.
Vodafone have doubled their network coverage, so you can get your business out there.
Data without context doesn't tell the full story. Understand why with SurveyMonkey. The engineering design process is a lot like making tacos. Here's how. Let's say you've had a long day. Maybe you've gone to class. Maybe you just got off work. Maybe you just finished an intense workout session. It's now 7 o'clock and you're hungry, but you've got friends coming over in half an hour. So what do? You go through the engineering design process. First, you define a problem or need. In this case, the problem is you're hungry and you've got people coming over in half an hour, and they might be hungry too. Next, you do some research to figure out the design requirements and your limitations. So in this case, you discuss things like ingredients you have at hand, money you've got to spend, how much time you have before people start showing up, how many people you have to feed, and if any of those people have dietary restrictions. Once you've got a pretty solid list of criteria and constraints, you can start brainstorming ideas for solutions. Maybe you look online at nearby food options. Then, maybe you go to the fridge and you start figuring out what you can make. You weigh your options and you determine making something at home will be cheaper and faster than ordering something online. And you decide everyone. You've got the ingredients to make guacamole. You make the guac and you add it to the tacos. It's
Vodafone have doubled their network coverage,
Sorry,
so
guys.
you can get your business out there.
So you start making some veggie tacos. You try one and think,
This is kind of dry.
you have other people try it to get their feedback. Most people agree. It's kind of dry. So you go back to your kitchen and start iterating again. You find that you've got the ingredients to make guacamole. You make the guac and you add it to the tacos. You test out and you're like,
This is tasting pretty good.
but some of the other testers think it could use some spice. So you evaluate their feedback, you look in your kitchen, and you realize you don't have anything spicy. That's when you call your friend Sam who's coming over. And you're like,
Hey Sam, can you bring over some hot sauce? I'm making tacos.
and Sam's like, sure. Also, I love tacos. It's now 7:30 and your friends start showing up. You tell your friends,
I made tacos if you're hungry. You can add hot sauce if you want.
and then you and your friends eat the tacos. They're like, these are pretty good. I'm gonna Instagram that.
You should share the recipe online.
So you do. You've solved your hunger problem and engineered a taco party.
Okay, thank you for watching, guys. Hopefully you learned something from this video. And here is the design process, so like diagram or schematic diagram of the design process. So the design process is dealing with a problem. So mainly we have a problem. So the first step is to find or define the problem, which is the design brief or the design story you will be following. So this will include criteria of design, constraints, function and structure requirements. So, for example, you are designing a shed, so you need to know the dimension of the shed, the location of the shed, what is the requirement of the shed, like if it is mezzanine floor shed, for example. Where is the location of the shed in the backyard, for example, close to the gate or close to the fence, something like this. So all of this information you need to gather as a definition of the problem. Then you will make information search, this including design data from other consultants' leads, so that you can do your own research, ask other designer who design similar structure in the area, or consultants who did executing or constructing same shed in the area, so that you can gather some information about type of loads, the soil profile in this area, and so on. Then after you have a long trip of thinking and investigation, so you can propose the structure system, which is the conceptual design. The structure system means the type of system you are using. For example, it is like rafters with columns and purlins bracing, or it is a reinforced concrete structure. And also need to know like spacing of major member, fixity of the connection, like beam connection, fixed connection, what is the construction techniques you will be following. Then this will lead you to, after you decide the structure system, so this will lead to the preliminary design and selection. Then the final step is the detailed design. So after you decide all the design, the sizes of the member and the location of the members and the connection between the member, so that you can produce the drawings and specification, and you can provide the construction manager or the builder about the construction. So after the construction is done, so your job is done. So that this is like schematic diagram of the design process, so that you can understand the design process. So what are the stages of the design process or the structure design process? So the first step is selection of structure system, which including the load base, lateral load base, and gravitational load base, so that you can find a specific base of the load from the top of the structure on the, for example, the roof sheeting until reaching the ground. And also need to decide what is the material used. For example, if it's steel structure, so you will be using structural steel. Then after the system is selected, we have the structure analysis. Structure analysis includes the loading calculation, reaction calculation, and so on. Then after structural analysis, we have a structural design, which includes the capacity of the member and load combination, which we will know now. Then the member design means selecting a suitable cross section for each member. Then after you select the member, you will do your final checking. So your final check, because sometimes we can make errors or some step was not performed correctly. So you need to do a final check. Then after the design is finalized, you can start producing the drawings and detailed drawings. Then after that, the construction manager is checking the detailed drawings from the structural engineer to start the execution of the building. So then the supervision during construction. So as a construction manager, you will be supervising the builder and other professional worker in the construction process. Okay, so all of this are steps come under the structure design process. And here is a video about the basic procedure and structure design. I will leave it for you to watch later. And here is some issues in structure design process. So some issues we can face during the structure design process is the environmental issues, and also some problem to achieve the sustainable building design. Another type of issue is the economic issues or financial issues due to material costs changing rapidly, and also availability of the material, and also higher or high labor and fabrication costs, and whole of life cycle cost of maintenance. So all of these are related to financial issues or economical issues due to high cost of materials and labor and maintenance costs. Also, in some cases, we have refurbishment costs, demolition costs, and contract type costs. So all of these are some of the issues that can be faced in the structural design process. Other type of issues is the constructability issues, which can delay the ease of construction. So some type of structure are not easy to construct or build because it is complicated structure. So this can cause issues, and also some details of the structure is not common, so it is not easy to execute. Other issues is the occupational health and safety issues in some location or in some type of structure. So these are some type of the issues we can face, like occupational health and safety issues. And in this image here, we have some example of the environmental issue. Okay. So this is a video you can watch later as well. Or the link of this issue here, and the link of this another issue about occupational health and safety issue is here as well. You can watch this video. And here in this slide, we will start looking at the structure design philosophies. So in the real life or the design, the designer have two philosophies in the design, which are the working or allowable stress design method and limit state design method. So actually, we will not be using this one. So the one we are focusing on is the limit state design method. But this is just a comparison for your knowledge. So before like for example, in the 80s and 90s and early 2000, they were using the work or allowable state design. And after that, they are using the limit state design method. So a design philosophy is set of assumption. So this assumption was set by the designer and standard committees and so on, which are used to meet the condition of self-stability, safety, economy, and functionality of the structure. Several design philosophies have been introduced in different parts of the world, and as I mentioned, we have two of them. The one we will be using is the limit state design method. So just for your knowledge that we may have different philosophies, but the philosophy that is common now is the limit state design method. So what is the idea or the concept that the limit state design method was built on? So the limit state design method is built on that we have this formula here. This formula is two parts, right hand and left hand side. So we have two sides of the equation. The right hand side of the equation is the capacity of the structure or the member. And on the other side, the left-hand side, we have the applied forces or applied loads. Okay, so the criteria of limit state design equation or design method that we have two terms. To make a safe design, we need to have the applied load less than or equal to the capacity of the structure. So if the capacity of the structure more than the applied load, so this is a safe design. The idea here is the capacity because of the factor of safety. As I told you, we need to have a safety margin or factor of safety. So we have reduce. We assume that because we don't trust the material available in the market, so you just assume it is reduced. So reduced capacities, the reduction factor is 5. So 5, for example, is 0.9 or 0.8 or 0.75. This is from the standard. So this reduction of the capacity. So here on the other side for loads, it is the reverse. So you assume that you have increased loads. So for example, you are designing a house. So you, for example, you design a house that can carry 10 people, but if they have like a party or something like this, so in some cases, the life load is increased. So that in the design, the designer should increase the loads. So we have these factors here, gamma and psi, to increase the the load. So for example, it is 1.5, 1.25, or 1.2, or 1.5, or combination of all of them. Okay, so again, the idea is we are increasing the loads expected and reducing the capacity expected, but to make a safe design, the applied load should be less than or equal to the reduced capacity. So in our course this year, we will firstly calculate the load. This is our first step. Then we will calculate the capacity to make sure that the capacity is more than the applied load. So this is the meaning of the design procedure using the ultimate limit state design method. And this is some explanation or some definition about it. So the aim of the limit state design method is to have acceptable performance under variety of different loads scenario. So the aim of any design method is to have acceptable performance under various loading scenarios. For limit state design method, we have two criteria or two main criteria we are using in this semester. So we have serviceability and strength. So we have two types of limit state design. We have serviceability limit state and ultimate limit state. Serviceability limit state dealing with day-to-day loads. So it is dealing with normal loads. This serviceability means we need satisfactory performance under surfaces under common action. And this method or this criteria is considering or concerned about cracking or bouncing and the appearance of the building. So mainly serviceability means deflection or any vibration or any other deformation. So in serviceability, if you remember earlier, we saw a bridge that has been deflected like that. So this is deflection. So in the serviceability criteria, we need to make sure that the structure will not deflect excessively. Because if it is deflect excessively, so the appearance will be not satisfactory, and the function will not be achieved. Also, there will be more cracking or bouncing, so that when we design for serviceability, we are considering the deflection design or the deflection check. For strengths, we need to avoid failure in lifetime of the structure in rare occurrences. So in this criteria, we are assuming extreme loads, which is rare in rare cases. So we just try to expect the building will fail, so that we will assume that we have extreme loads. So the difference between here and here is surface or day-to-day loads, here is extreme loads. Okay, so this will ensure safety for all occupants of the building, will also ensure that no failure or collapse for the building, so that when we design for limit state, we need to consider these two criteria, serviceability and strength. There are some other limit state design can be found in the standard, which we are not dealing with in this course. So, for example, earthquakes or fire or fatigue and so on. Okay, so this is the scenarios or the criteria of the limit state design. Okay, what are some example of day-to-day loads and extreme loads? That's a good question. So it is quickly here. What are type of loads we mentioned earlier? Loads. We, for example, have dead loads and live. Okay. So the serviceability limits, I will give the sample, the symbol for dead load G and the live load B. This is in the, sorry, Q, not B. Q, G and Q. So G for dead load, Q for live load. We will know that later now after this explanation. But if we have dead load and live load, so the surface loads are G and the Q without any multiplication or any increase. The ultimate loads, for example, 1.25 G or 1.2 G plus 1.5 Q. This is from the standard. So as you can see here, what means by surface loads? Surface load means we use the load as it is. So G or Q as it is. Ultimate loads means we have increased the dead load or live load by percentage. For example, here 25%, here 20%, here 50%. Okay? Do you understand what is the difference between day-to-day loads or working loads and ultimate loads? So the ultimate load means increased loads with the factor of safety, 25%, 20%, 50%, or so on. Surface loads means the load as it is, G and the Q, dead load or live load or wind load as it is. Okay? Do you have any query about that? Any other query? No? This from the standard. 1.25 is from standard, but this is just, I give you an example. So we are not using G as it is. We have increased it by 25%, so it become 1.25. So for comparison here, we are using 1 G or 1 U. Here we are using 125 G or 1.5 Q. So here the factor is 1, here the factor is 1.2 or 1.5 or whatever the factor is, but it is more than 1. Yeah, we will get this one now. It's just standard. In the standard give us that. We don't assume it or we don't calculate it. The standard will give us these factors. Okay? Yeah, it is being given. Okay. Okay, so this is just explanation of what is the ultimate load and what is the surface load. And this just some figure showing you the different criteria of the two limit states we are concerned about, the serviceability and ultimate limit state. So the first one is ultimate limit state here. So we are dealing with collapse, overturning, or buckling of the structure. So this ultimate limit state is dealing with failure of the structure. The failure can be total collapse or overturning like that or buckling. The second limit state is the serviceability limit state, which as you can see here, for example, deformation or like drift of the building. So the building should be vertical like that, but it has a little bit drifted. Cracking in the building. So this can be also one of the serviceability limit state points we are looking at, and also vibration. So the serviceability limit state not dealing with failure, it dealing with deformation or deflection of the building. So this is the difference between both of them. So the structure will not collapse under the serviceability limit state, but it might be not fit to use or not functional to use. Okay, so here is some of the symbols of the load we will be using during our course. So because the standard, the Australian standard give us the symbols directly, so that you need to know what is the symbol of each load. So dead load or permanent load is with the term G or the symbol G. So G is the dead load. Live load or superimposed load is Q. So G for dead load, Q for live load, and W for wind. So W for wind load. Earthquake load has a symbol E, but we are not considering earthquake or soil pressure or liquid pressure or other loads, temperature or settlement or fire. So in our work, we will have only three terms of loads or three symbol of loads: G, dead load; Q, live load; W, wind load. Okay, so these are the loads we will be using. And here in the last step is the example of load factors and load combination from 1170.0. So please have a look at 1170.0, which give us the load combination. So you were asking about where to find the factors. So here for strength or ultimate limit state design. So ultimate limit state design, we have this load combination. So today we're just introducing the terms, not going in details, but I just want to show you some example of the ultimate limit state. So here, for example, the first load combination is 1.35 G. So 1.35 G, if you are having if you have a load combination for only dead load. So if you have dead load only, your load will be 1.35 G. This for ultimate. For serviceability, this is the difference to show the difference. It is G only. So for serviceability G, for ultimate 1.35 G. The second combination is 1.2 G plus 1.5 Q. So 1.2 G plus 1.5 Q. So the standard will give us what is the factor to use. Here, for example, for ultimate, it is 1.2 G plus 1.5 Q. For serviceability, it will be G plus Q. So this is the difference between the two methods. Ultimate, we increase the load. Serviceability, we use the load as it is. For example, the first one here, we have 1.2 G plus WU plus psi CQ. So we have 1.2 G plus WU plus psi CQ. So as you can see here, we have 1.2 G WU as it is, but here we have WU. In the serviceability, it's called WS. So U for ultimate, S for serviceability. Okay. And we don't use the sorry, this one we don't use the earthquake ones or the snow one. The first one we have E D equal to 0.9 G plus WU. So we have different cases of combination based on the type of load we have and also the design we are doing. But the main thing I want you to understand today is there is a difference between the loading in serviceability case and the ultimate case. For the ultimate case, we are dealing with, for the ultimate limit state here, we are dealing with factors more than one. So 1.35 G, for example. Here we are dealing with one. The factor of the load is one. Okay? We will go through this in the next lectures. So don't worry about that. What is the final bit of the it is psi. This factor is called psi. Psi is a factor we will be using in this combination. We will explain in the other lecture. Okay? In the coming lecture. You don't need to understand all the factors or the symbol today, just introduction to the concept. So we will be going in depth in the next few lectures. Okay. So the standard give us all the parameter needed. So if the standard mention psi, so he will give you, the standard will give you what is psi. So you can find in the tables what psi and when to use the value of each factor. Okay. Okay, guys, do you have any other query before we end the lecture? Thank you, Syuk. Sorry, Rehan, what you mean by Monday and Tuesday? Next Tuesday is not a holiday. Only Monday. Next Monday is a public holiday. Okay. So no. And if you have a table on Monday, we don't have structure to lecture on Monday. We have only Tuesday and Thursday. So lecture on Tuesday from 1 to 3 and lecture on Thursday from 3 to 5. And the classes is Wednesday. And also let me check. Any of you has a class on Monday? Okay, I will share the screen. Can you see the screen now? So there is nothing Monday in the class. So we have Tuesday, Thursday, and all the classes on Wednesday. Maybe you check your timetable. Maybe it has something wrong, but we don't have anything on Monday. So I will meet you tomorrow in the face-to-face class, and next Tuesday in the superstructure class, because we don't have substructure class this week. Okay? All good? Do you have any other query? Thank you. See you tomorrow. Any other query, guys? You mean for other classes? Yeah. Okay, for other classes, there will not be, thanks, Rose. There will not be, if it is public holiday, so there is no election. Okay? So I just thought you are talking about our class. So for other subject, if there is no, if it is Monday, so maybe they will make a makeup class or makeup lecture, or it will be just dropped. Okay? All good? Any other query, guys? Yes. All good? Thank you guys for attending today, and I will see you tomorrow and next week. Thank you. See you.